We are recording, I think. Don't know whether the sound's working or not. Right, so just say what you've got so far. The knowledge that you should have at this stage is to be able to calculate the areas of what shapes. Hang on, stop. Trapezium, triangle, rectangle, square, parallelogram, a quadrilateral. Well, only if. So a kite we can do, that's a quadrilateral. But could we work out the area of an irregular quadrilateral? No. We haven't done that, have we? Do you know what I mean by irregular? You might, well, actually at this stage it depends what I gave you, but we've kind of relied on more kind of, not regular as such, but regular in terms of it's a rectangle, or a rectangle with a triangle on the end, but we know that as a trapezium. Good. Right, so we can work out that. Triangles, any type of triangle we can do, because we looked at that. But we haven't gone past quadrilaterals, and we can't really look at irregular shapes at the moment, because it doesn't necessarily work so much. So you've done all that, so are you happy with what we've written so far? So I'm going to come back to that if you've written it. Let me just check then. So if we've got, just as a recap, again, you don't have to write this because you should have already done it in previous notes. What's the area of the triangle?
Base times height.
Okay, base times height divided by 2. Good. Who wants to be specific about base and height? Who wants to tell me something?
So it's like the bottom.
Is it?
It's what?
Okay, so which side of this triangle would have to be the base?
Anyone.
Any of them, yeah. That's important, isn't it? Any of the sides of that triangle could be the base. And then?
The height would be, would have to come from the highest point of the triangle, cutting down perpendicular to the base.
Okay, so the only issue with what you said was if the base isn't the bottom, the highest point of the triangle isn't necessarily going to be the highest point of the triangle unless you rotate it. So the one specific thing we keep about what you've said is it must be perpendicular. So for instance, if I choose this side here as the base, right, the height would actually be from this line to that point, okay, and it must be perpendicular, yeah? So I don't know whether I haven't drawn that very well at all, have I? It's weird at a funny angle. So we go to that point, so that there would be the height, wouldn't it? So that line. So just one thing, just to recap, the height does not necessarily have to be the height, but it must be perpendicular to what you decide is the base. Now, why might the base not be the bottom of the triangle?
It must have been, so the base could have been any other place in the triangle.
Yeah.
It's just.
And why would it be somewhere else in the triangle, not on the bottom? Because that's what your teacher wrote. You know.
It's just a fact.
The number could have been put anywhere and you weren't together. So, yeah, so the base could have been anywhere just because I could have decided. If it's a problem-solving question, you might be trying to find the area of a triangle in a complex shape, like we're going to start looking at. Therefore, the base that you know, or the side of the triangle you know, might not be at the bottom. It might be somewhere else in the shape. Yeah.
So you see how any side could be the base. So if you were to do it's still a triangle, but it's a bit shorter, longer.
Yeah.
So It wouldn't mean you have to turn the shape around and make the sort of bigger base when you're not.
No, definitely not. But for instance, if I have a triangle like this, okay, all right. Now you're going because you're looking at it one way. Now I could do one of two things. I could make that the base, therefore the height would be there. Okay. Or I could, if I try and draw a similar one, okay. Or I could make this the base, then the height would be, I'd have to extend up, and the height would be that distance. Okay? Or, try and draw the same thing again. This is why these ones are relatively interesting. Okay? Or the one side I haven't used yet is this one. So that could be the base. And then the height again, well, I'd have to extend and go, and that would be the height, wouldn't it?
Couldn't you just go, wouldn't it just be straight down through that?
Well, it can't be through the triangle if the base is, if I went there, look, if I went from that point, it's not.
No, I mean the other black line. That's not perpendicular to the base. Oh yeah.
That one? No, exactly, it's not perpendicular, exactly what you just said. So those are the deals. So when you've got a triangle like that, you know, as long as you find with all of them the height has to be perpendicular to what, it doesn't have to be attached, okay, but it does have to be perpendicular. Make sense?
Yeah.
Okay, so we've got triangle. We've also got, I'm not going to do rectangles because you know rectangles. What about parallelogram?
It's the same as everything.
Same as a rectangle and very similar to a triangle in that it's, sorry, I'll do that again, base times the height. Now the height could be in it, outside it, whatever you like, but it's like a triangle but without the, so area is just base times height. We then had a shape like this, and a shape like that is called a trapezium, and remember we had A, B, H. Again, the height has to be perpendicular, so the area of this is, so the area is?
Divided by, no, times by H, divided by 2.
All divided by 2, that's normally what we say. Okay. Pardon? No, it doesn't matter the order which you do this. Okay? And that's the same, isn't it? So that's nice because it's right angles in the trapezium. However, like we did with the triangle, we may have to consider that we have a shape like that.
So you have to do it.
Okay, so the height would be that. So we can't use the sides of the trapezium necessarily.
Isn't it like length 1 plus length 2 times the height?
Yeah, so again it's A and B, and this is the height this time. So again, with all these things, don't necessarily just multiply the sides together. Alright? Now, let's go back to our objective. So, composite shapes. So there's one of two things I really think about. We could either have to break the shape into smaller shapes, simpler ones, and then work out the areas, or we might be a situation where we have to subtract one from another. Okay, so if you have a look at page 246, let's have a look at the example questions just to talk through. Right. So one of these questions, we have a rectangle, and then there's another rectangle which they say is kind of cut out. Alright? and we're given some information like it's 3 meters and 6 meters for that one, and we're told that it's 9 meters for the big one and 8 meters. Again, definitely not to scale. Alright. So if I said to you now, work out the green area. Right? The green area. Now, I know hands have gone straight up. Is there anyone that doesn't know what they would do at this stage? Keep your hand up. Be proud of the fact that you need some help. It's good. Alright? So, there is one on each table. Awesome. I would like one of you to explain to the rest of us. That means everyone on your table now has to explain to you. Alright? So, great. I think you've decided. Anyone now just talk me through this example? Serena. Well, I'm just going to write my notice. So I've got to do the full green rectangle. Okay? And I'm going to subtract the orange rectangle. Right? And that will leave me with just the green round it, won't it? So the full green rectangle is? So it's 9 times 8.
Oh, so it's... Wait, are we doing...
Doing the one on the board. That's why I'm writing next to the one on the board. So 72. And then the orange one is 6 times 3, which is 18. So for the green area, we do 72, take away 18, which equals... See, what I do is take away 20, and then add 2 back on. So 52, add 2 back on, makes 54. And the units are? No?
Meters. Oh, meters.
Square meters, yeah. Good. Okay. So it's a simple example of, this is one way you take away. Hey, do you want to get back into your book now? So I'm actually writing. Okay. Now, looking at, just so I do another one with you, I don't want to do too many of them with you because some of you definitely don't need it. Let's have a look at 1C. Alright, and they've given you a bit of a clue. Alright, they have definitely given you a bit of a clue. So, we have this situation. Okay. Alright, and then we've got some dotted lines to finish it off. Now, what I just want to talk about is the symbols that have been given to you, the notation that have been given to you, which is they've given you this line, they've given 2 there, and they've given you this one, and then this one. Okay, be very careful. You've been told that's 3 meters, that's 2 meters. Right. That's, I think stop. That's 5 meters and that's 4 meters. Alright. So could we analyze the information we've been given and tell what that means? So again. Is there a line of symmetry? There is. About what? This 3?
Halfway through,
Does the line of symmetry, does it matter, the line of symmetry?
It'll have to be like the...
This, so, I mean, I don't know. And think about the measurements and things. What are you told? What do the little lines mean? And they're the same. So this one here, this is 4. So with the 2 lines here, that means that. Okay, so the one up there is 4 meters. And then this line here means that it's the same, which is 3 meters. Okay. Now, because it's a rectangle, the big thing is a rectangle, that means this is also 2 meters. Now, we've probably written, and this one would be 5. Do we definitely know that? Has to be, doesn't it? Nothing else. If that one here has got to be 4 meters, that has to be 5 because we've got a rectangle. So we want to know the area of this shape, the shaded shape. All right. So we can either think of it, is it a breaking it up into smaller shapes, or is it a subtraction one? So subtraction. So what is the process that we go through, the neighbour?
You could know the area of the entire rectangle.
Awesome. Yeah, we've got the entire rectangle here. So I'm just going to draw that. So actually, what I'm going to do is work out the area of the entire rectangle. So the rectangle there is what by what? 9 and 5. So the area is 45.
And the 2 triangles are 6.
Okay, so so we've got the triangle 1 and triangle 2. So what's the area of? So I'm going to draw it like that. They're right angle triangles, which is nice, and I've got this one up here. Again, you don't have to put all these notes when you're answering. I'm just doing it to make it very clear. So this triangle is a 4 and a 3, and this triangle is a 4 and a 3, actually. So, go on. They're 6 each, good. And the units are?
Meters. Square meters.
Square meters. Okay.
And I forgot another thing. Since
Yeah.
the 2 triangles the same, it would look the same as one triangle. As in, like, if you do just 3 times 4, then that would be...
Yeah, that's one of those things. Do you remember on that worksheet I gave you? And there were lots of questions, and I said, right, got to get these all done as quick as you can. Yeah. Part of that is realizing that sometimes you can simplify it. Like, I've got 2 triangles that are exactly the same. Well, a triangle is base times height divided by 2. And if I've got 2 of them, I have to then multiply by 2. So you either divide by 2 and then multiply by 2, or you just realize that, put the 2 triangles together, and it just becomes a rectangle that is 3 by 4, and just do that. Okay? Not a problem if you don't, it's just a little bit of typing. So, nice and simple one, yeah?
Yeah.
Easy enough? Okay, I think, just before I let you get on then, I'm going to draw this in a very specific way for D. Alright? So I've drawn that rectangle, done it like that, and then I've got... Why do you think I've drawn it in that way? Sarah.
Breaking up the shape.
So this one we could, if we wanted to, break it up. So if this is 1D, I'm not going to do it necessarily with you, but just to talk through, I've got a line there, a line there, a line there. I'm told that that's 3 kilometers. This is 4 kilometers. All right. What else do we then know? Because we can break it up into 2, or we can make it all one big one and subtract.
Well, because the line shows that it's the same length for those 2, so we should put in that one is that where your mouse is now.
Yeah. So that's also 3 kilometers. This is also 3.
And by knowing that, we now know that the length, or I do, let's say 2 shapes, and we know that the length of the long, the length.
Yeah. So this whole length is
7.
because if that's 4, that's 3. The whole thing is.
7. So then what I would do is like 7 times 3.
So 7 times 3 for this rectangle is.
So the bottom one I do 3 times 3.
Which is 9. Okay, so 21 add 9 makes 30 square kilometres. Now, that's not the only way to do it, is it? I could have broken it in a different way. I could have split it like that if I'd have wanted. Is there any way of doing a subtraction one here as well?
Yeah, unless you made the that part into the other color.
If I just do one big rectangle and then subtract this bit, if I do a subtraction instead, I get the same shape, don't I? Same area. So this is what I call, just to explain it before I let you get on, this was breaking it up, but I could easily do a subtracting areas as well. This one, yeah, exactly. So if I was going to do it this way, everyone, just to finish off, I know that still that bit's 3. This bit I would still have to know that that bit's 3 and that bit's 3. I know that this bit's 4. So I know the whole length is 3 and 3, so it's got to be a 6. And I still know 4 and 3 makes 7 from before as well. So that's how I would do the big area. So 6 times 7. So 6 times 7 is 42. And then the area of the pink one is 4 times 3 is... Sorry, 4 times 3 is 12. Do 42, subtract 12 equals 30 again. So we get the same answer. We should hope so. Okay. So, what you need to do then is be able to do questions like this. Alright, so have a look at the rest of exercise 11E. Right. Obviously the question like 4, we've just done one like that, but adds a little bit to it. Question 5 and 6 are the more challenging ones, but have a go through, pick the ones you think, make sure you've got all the knowledge you need. Alright?